All right, this presentation is on IP addresses and domain names. IP addresses are very important because they are how packets are labeled as they cross the internet, whereas the domain names are how we remember who we're trying to communicate with. So think of this as being a bit like having wanting to call someone on the telephone. You can't just dial their name. You have to have their name mapped to a phone number, either in your phone's address book, or you have to somehow look up what that phone number is that's associated with that person. Because you can't dial their name, you have to dial their phone number. In the old days, we had printed phone books where you could look up the person's last name and then their first name, and then you would hope that there weren't more than one person with the same first and last name, or that you at least knew where they lived, so because their address would be included in that. It was kind of a pain. But your computer is set up so that when you type in sbhs.sbschools.net, it does that lookup first, and then takes the IP address that it gets and puts that on as the destination IP address. And it puts its own IP address on as the source IP address. Every packet on the internet has to have both a source and a destination address, or it will not be transmitted. So currently we're using IP version 4. It's 32-bit address that we represent in something that we call dotted decimal. Now, there are only a theoretical maximum of 4.3 billion IPv4 addresses available. We have at least twice as many people as that in this world. So there's not even enough addresses for each person to have one address. On top of that, we often will use more than one address. If you have your cell phone on and your laptop at the same time, you're using 2 IP addresses right there. So we have come up with a few different ways of extending that IP version 4 address space. They're kind of kludges, but they work. And so that's allowed us time so that we can do the transition to the next version of IP smoothly. Now, this is the way that an IPv4 address is written, the dotted decimal format. We take the 32 bits, we divide it into 4 8-bit bytes, and then each of those bytes is represented by a number from 0 to 255, because if you turn all of the bits to ones, 255 is the largest number that you can encode. So this we would read as 172.16.254.1. The new version that we're moving to, we skipped IP version 5 and went directly to IP version 6, which uses 128 bits. Because we have so many more bits, we write them in hexadecimal notation because we can use a lot fewer characters. That number that it gives us is a very, very, very large number. There are different analogies for how many different addresses that is, but one I think that's very compelling is that there are enough addresses in that address space that we could assign a separate IPv6 address to every star in the universe times 1 trillion. So we could assign 1 trillion addresses to every star in the universe. That's a lot of addresses. Now, the format is more like this, where we write in groups of 4 hexadecimal characters separated by full colons. And because there are still, 32 characters here, that each represent 4 bits, we have a couple of schemes for reducing the length of the address. So any place in the address where we have an extended string of zeros, we can condense one of those strings of zeros down to 2 colons. So that just represents there's a bunch of zeros in between here. How many? We'll figure out how many you're missing. That's how many would be there. Now we also, and they didn't do it here, but we can also drop leading zeros. So this address would be written as 2001 colon DB8 colon AC10 colon FE01 colon colon. and that would represent all 128 of those bits. Okay, so there are a couple of different ways that you can find out what your external IP address is. Now, when I say that, you have, in most networks, you have two different IP addresses. You have the IP address that is configured on your device, and that is within a private address range, because this is one of the ways that we've found to extend that IPv4 address space. So what we do is we have everyone on your local network basically sharing one public IP address. We call the IP address that you have configured a private IP address, and the one that your router attaches as the source IP address as its public address. So you see in this case we're using a website named whatismyipaddress.com. And it reveals that our public IP address is 68.9.60.191. So that's an IP address that's actually assigned to your router. Now, in that example, going back to it, you'll see that it will show a map where that's located. That is not going to be where you are actually located. That is going to be where the connection from your ISP, your service provider, to the internet is registered as being. So in my case, I live in Bolton. My ISP is headquartered in Waitsfield, which is quite a ways from Bolton. So I come up as being in Waitsfield when I'm actually nowhere near Waitsfield. Now, this example shows looking at the same information on a cell phone that's on the same local network. And you can see that the IP address is the same as it was on the previous slide. 68.9.60.191. Because again, both of these devices are represented externally by the address that's on the router itself. If we then look on a cell phone's cellular connection and not a Wi-Fi connection, it's going to be a completely different IP address because it's through the cellular service provider. So in this case, 107.77.106.60. And so that's associated with AT&T mobile instead of, in the previous case, I think it was Cox Communications because it was probably a cable connection. Now this diagram indicates how most home networks are set up. And this actually is extended, our school is set up the same way. So you'll notice that there's a router, and this is a multifunction Wi-Fi router that is really the demarcation point of your local area network and the outside internet. So devices that don't need to communicate with external devices, which might be like your computer and a printer that you have at home, you can go directly to that. So the router knows that that traffic stays local. Whereas if you've got something that's going to Google, then it's going to be going out to the internet. So you can see from the addresses here that all of these devices have addresses that start with 192.168.1, and then the last octet is different. Okay, it's going to change for each device. The router is going to be the gateway. Now this diagram, the modem is labeled as the gateway, but it's actually the router that is the gateway, the way out of the network. And you can see that it has typically, and you'll see this on most home routers, it will have the address 192.168.1.1. So if you do an IP config at the command prompt, so you hit the Windows key, type CMD for command, up will pop up a little terminal window. And if you type in ipconfig and hit enter, you'll see what address internally that your device has. And you will also see what the address of the gateway is. And chances are they're going to be very similar to these. Now the router also has an external interface that's connected to the modem. And that one will have the public IP address. So I'll use the one from our previous example, 68.9.60.91, and that is what the rest of the world sees you as. So the router keeps a little table in its memory so that when you are requesting a web page, it remembers that request. And then when traffic's coming back as an acknowledgement of that request or in reply to that request, the router knows which device on the network to associate that with. And it puts your actual address back on as the destination IP address in that case. Now, in this case, we have a separate modem and router. That's not always the case. When it is, there will be an Ethernet cable between them. But if you're using a router that your ISP provided, chances are good that the modem and the router are actually built into the same device. So what then you'll have connected from the modem back to the service provider is either going to be a cable connection if you have cable service, or a telephone line if you have DSL service through a telephone company, or a fiber optic cable if you have a direct fiber optic connection. And then your ISP has their own network, and at some point your ISP has its own gateway out to the internet, and it's that gateway that will be represented on any map. Now, the domain name system, as I said before, is a sort of a telephone book for the internet. And it's an ingenious system that was originally developed by these two people. When there were very few devices on the internet, there was simply one flat text file that was kept on one server, and any device that needed to look up a domain name went to that one server, and that server used that flat database to come up with to map that to the IP address. So Elizabeth Feiner came up with a more distributed system for keeping track of those, and a more dynamic system, partially because she was the one responsible for maintaining the flat database, and she realized it was not scalable. John Postal is the one who came up with the whole addressing scheme, and he was also critical with connecting that addressing scheme with the domain name system. So they even though they weren't really working together, they did work together to develop this. So now we have a hierarchical network of DNS servers, and it's critically important. These are, if you were going to take the internet down, remember it was designed to be a distributed system that was that had high reliability, because you could break a lot of links in the internet and there would still be paths for the data to get to its destination. And it was designed to be self-healing, but that's for the data to travel. If you really wanted to take down the internet and make it so that people couldn't use it, you would go after the DNS servers, because if people couldn't look up the addresses, they would not be able to access the information. So the people managing this system take security very seriously. So we see that in this example that we have the domain ru.wikipedia.org, which is the Wikipedia servers for the Russian language Wikipedia. Now, you typically, when you want to go to Wikipedia, you just type in wikipedia.org. Well, that's because you're not having to type in the www. It's implied if it's not specific. But that only gives you the English version. So you get the English version either by typing in wikipedia.org or www.wikipedia.org. If you wanted to get the Russian version, you have to type RU, because this one represents the actual server. Now, when the domain name system was originally set up, there were several three-letter top-level domains, or TLDs, and they were .com for commercial, .org was intended for nonprofit organizations. Now anyone can register in the .org space if there's an address available or name available. .net was for networks, for ISPs and other providers. Again, that's also one that anybody can register a domain in the .net now. Didn't used to be that way, but it is now. And then there were also .edu for post-secondary. You have to prove that you are a post-secondary institution in order to be able to register in that domain. And there is also .mil for military use. And again, you cannot just go and register that. You have to be in the military You have to be a military installation in order to have one of those. Then there were a whole series of two-letter country codes. Every country had a two-letter code assigned to it, whether they had internet connections or not. And those still exist and are still used. If you go to a website in Britain, England, it will almost certainly have the .uk two-letter domain, top-level domain tacked on to the end. So now we have the Wikipedia part. So Wikipedia is registered in the .org.tld, and then within Wikipedia, we have RU. So when Wikipedia registered their domain, they registered as wikipedia.org. They didn't have to register the RU, but they do have to set up a domain name server mapping to the ru.wikipedia.org to a specific server. But they can manage that internally. Interestingly, I think Wikipedia pays the same $15 for their .org domain every year that you would pay if you wanted to register a .org domain. No real difference, in spite of the fact there's a tremendous amount of more traffic that goes to the Wikipedia site than any site that you're likely to create. So here's another example. This one has 4 different parts. So we still have the TLD, and this is the .edu one. Then we have TrinCol for Trinity College. So Trinity College has trincol.edu as their domain. Now internally, they've divided up so that they have subdomains for the different schools, the different departments. So this is their computer science department, has its own subdomain. And then Turing is a server, a specific server within that subdomain. So the entire address for their website would be turing.ces.trincol.edu. Right? Now, if you want to do a lookup, one of the ways you could do that and find out what the IP addresses of these different servers would be is to, again, from a command prompt on your computer, try pinging them. If you type ping space mit.edu, you will be sending a series of 4 very small packets across the internet. And if MIT's web server is configured to do so, because they can ignore those pings, they'll reply. And you can use that request and reply to figure out what the latency of that link is. You know, how long does it actually take my packet to get there and come back? It's a diagnostic tool that's used to figure out when you're having problems. But one thing that it does is, since it has to translate that address, it reports that IP address that's associated with that server back to you. So the first line that you get in return will be will include the actual destination IP address. So that's a very commonly used way to look up IP addresses. There are other ways as well, but you can see that these are all have different numbers that they start with because they are in different domains. Now, the domain name system is kind of ingeniously set up as a hierarchical system. There is only going to be one name server that has the actual mapping hard-coded in its database. And that is your authoritative DNS server. So in this case, that's the bottom one here. But when you request that, your computer doesn't know which name server is the authoritative one. So what you do is you ask your local name server, and you can also find this out through ipconfig. If you type ipconfig space and then add a / and the word all, so ipconfig /all, you will get some extended information about your IP configuration, including what your name servers are. So these are the first ones that you check when you need to do a lookup. Now, those servers may or may not know the actual address. So if they don't, what they do behind the scenes is first they go to one of the root name servers. And these are these massive computers on the internet that handle a lot of this. And that server may have the address mapping on it because someone else may have done a lookup for the same address. Certainly if it's something like google.com, they're going to have that mapping already in there. But if it's trinitycollege.org, maybe not. Maybe nobody recently has gone to there from there. So what that root name server will do is it will go then to the TLD's name server, so in this case the .org, and say, hey, do you know what the trincol.org IP address is? And if that server doesn't know, because it doesn't have it cached, it will then look up who is the authoritative name server for this, and in a separate table, and say, oh, there it is. So it will look it up, and then it will pass it along back, and each of these name servers in between will then be able to update their own databases. So for a period of maybe as long as 3 days, they'll actually remember what that address mapping was, and be able to provide it more quickly without having to go down through the whole system. So it's a system that can self-learn, but there's only one place where the actual mapping is made, so that if you decide you're going to change the IP address of the name server or the web server, you can go and make that change in one place, and it will eventually cascade through the whole internet. They say it will take up to 72 hours when a change is made, but in reality, it usually happens much quicker than that. So here's your task. Find a domain name that's available. You don't have to register it. That costs money. I'm not going to ask you to pay money. I have occasionally had students who have, because typically students will start looking up their own name. Now, if your name is a common name, it will almost certainly be already taken. Somebody's already grabbed it. But if you have an unusual name, like the one I've chosen here, you might find that it's actually available. Should you register it? Well, maybe, maybe not. Certainly if a professional who wants to have their own website would almost always love to have their own name. And if your name is available, now might be the time to grab it before somebody who also has that name does. And later on, if you come back 5 years later and you say, yeah, I'd really like to be joesmith.com, and you find, oh, it's not available anymore. Bummer. But for this case, we're going to look like, now, I would recommend only looking it up on the .com domain if it's your name, because you probably don't want to register your name as yourname.org or yourname.net, because those imply different things. You can't look it up in the 2-letter domains because that's a different system, and that has to be geographic based. There are some new top-level domains. Anybody now can set up a top-level domain. It is very expensive to do so. It's not something individuals do because it costs many thousands of dollars, and there are significant ongoing expenses. But people will often buy domain names under these because they like that top-level domain, like they want to be .runner. These usually cost a lot more. So that's why if you have a .com available, you might want to grab it. So I would like you to look up a domain, find a domain name that's available that makes sense. Don't just do abc123.com because it may be available, but that's probably not one that you're going to want to use. Actually, that might be a pretty good one, but some random string of characters that isn't going to be easy to remember wouldn't really make a lot of sense. But you might say, well, maybe I would want a domain name for my, some interest that you have. You might find that there's a legitimate domain available that would support that. Now, some things that people often ask, registration costs, if you were to register a domain name, usually between $10 and $20 a year. You can always find places that will charge you a lot more money than that. You don't get anything for your extra money. Sorry. The cheapest is going to be the best. Anybody can register any domain name that is available. However, if it is a trademarked word, you would almost certainly lose a court case if the company who owns the trademark comes back after you. So don't think you're cute if you find out that Coca-Cola.com is available, and you know Coke is going to want to have their own website on their own domain. Obviously, they've had their own for decades now, but you know, you can register it, you can hold it. As soon as they want it, they'll send people with shiny pointed shoes to your house, and they'll say, give it back, and you won't want to fight that battle because you'll lose. Now, the problem with registering a domain name if you're not going to use it is if you're not prepared to re-register it every year and pay for it every year, you might forget. And if you do, you will probably not want to try and get it back, because the cheapest it'll probably cost you to get it back is maybe $300. It could be a whole lot more than that, depending on how long it has been since you let it lapse. There's a whole scheme of cashing in on domain names, and quite frankly, they figure if somebody registered this domain, somebody thought it was valuable, so I'll grab it, and then if they want it bad enough, they'll pay me to get it back, or maybe somebody else would like it too. So there's a whole structure of that's really intended to take advantage of people who forget to renew their domain names, and make it very expensive for them, basically holding it hostage. I generally suggest that if you are thinking of starting a website, you do not register the domain through the hosting provider. Hosting providers will sometimes offer to do that for free for the first year or 2 years, but then they own the domain name, not you. And if you decide you want to switch to a different hosting provider, you may find that that you won't be able to get your domain name to take with you. Now, if your name is available, should you register it? Entirely up to you. I think I've had 3 students over the years who have done that. Not very many, but hey, if you're thinking that you're going to have a career as a professional, and that it might help to brand yourself, certainly branding worked for Donald Trump. So having your own domain, your name and your domain name can be really powerful. So I doubt that you would regret it if you did that. But remember, don't forget to renew it. If you get poverty stricken as a college student and $15 is a hard thing to come up with, you might wish that you just left Joey Potovinsky out there, because who else would want it? All right. So that's your task. Include that information on the domain name that you found that's available, that you might think about registering, in this week's assignment. And we'll see you next time we're in person.